In this video series, we will learn from OpenAI Cookbook. Okay, so OpenAI, they have created a number of notebooks about their large language models, the APIs, the ChatGPT, embeddings, as well as their image models like Dolly and also audio models like Whisper. Okay, as you can see from here, this repository is quite popular. It has received over 40,000 stars. Okay, so what I will do is we will go through some of these very useful and interesting notebooks, and we will learn from them. All right, so you need an API key. What you can do is you can just head to the OpenAI, sign in using your Gmail, or you can create a separate account. Just go to API keys and you can get your API key for free. Okay, so the free version, it comes with $5 credit, but that's enough. That's more than enough for this course. Okay. All right, here you can track your usage, etc. as well, right? So I just created this account, so I still have my $5 credit. And yeah, copy the key to your environmental variables so that you can use their APIs. All right, coming to the price, it's quite cheap. At this URL, they have listed their pricing. So we are mostly going to use embedding models, at least in the first part of the series. So we will be working with this ADA V2 model, which is very cheap. As you can see here, this is the price for 1000 tokens. Now the tokens are the number of words which we have in the prompt plus in the answer, right? So the tokens, it's the sum of what we ask and what gets returned. Okay, for embeddings, because we get a vector back, the number of tokens is simply the number of words in what we ask for. Okay, our document only. Whereas for other models like GPT-4 or chart, etc., what is get returned or the answer also taken into account when computing the tokens. Okay, so you can see the price here, but again, you don't need to worry. We'll be using only the embeddings, and yeah, it is very cheap. All right, and let's go here. Okay, before going to embeddings, let's understand why we need embeddings, right? And what we have before embeddings. Okay, so let's say we have some text we want to analyze, or we want to make sense of some text, or we want to classify, etc. Right? Any natural language processing NLP task we want to do. Now we know the computers, they can only understand the numbers, right? To be specific, only the binary numbers. So even these numbers, they gets converted into binary numbers before the computers does anything. Okay, so we need to convert the text into numbers, right? So before embeddings, the way we used to do is using simple methods like bag of words. So I just went to Google and search for bag of words, and you'll come across many images. So let's take this. Maybe let's start with the simple one. Okay. So let's say we have only these 4 sentences, right? Now what we do is we simply take all unique words. For example, okay, so here we are creating a new, let's say, matrix, and we'll find out all the unique words in these 4 documents. So for example, the red dog, cat eats, dog, which is already covered here, right? So that's not a new word. And then we have dog eats food. So food is a new word. So we have food. And in this 4th sentence, these 3 words we already have. So then what we do is, for each sentence, we'll check if the sentence has that word or not. So this first sentence, it has the, it has red, it has dog. It doesn't have cat, it doesn't have eats, it doesn't have food. Okay, so we converted this first text or document into this 111000. Now, throughout this course, we will be referring a word or a sentence or a paragraph as document. Okay, so when I say document, it could either be mean a word or a sentence or a paragraph, right? Similarly, we can convert this second sentence. So this does not have the red, but it has dog, and it has cat, it has eats, and then it doesn't have food, right? So that way we can convert the text into some numbers. Okay, this method is called bag of words. Now, in these sentences, we don't have any word repeated, but let's take another example like this. So here, as you can see, we have converted these three documents into this words list, right? Unique words list. And then about appeared once, whereas the bird appeared 5 times in this sentence. Okay. Similarly, the appeared 2 times, and we don't have heard, is, word, and you. Okay, so that's one method. We can either do this one hot encoding, or we can actually take the count of the words which are appeared. Okay, that's the simplest method. And then we have another method called TF-IDF, which I will quickly explain. So I came across a very nice blog from Rohit Madan. Hey, thanks Rohit for putting it together. So in TF-IDF, TF means term frequency, IDF means inverse document frequency. It's very easy. Let's take an example so that we can understand it. So what we do is, let's say we have 3 documents, right? So the first document is, it is going to rain today. Second document is, today I'm not going outside. And the third one, I'm going to watch the season premiere. So first, now we might do some pre-processing, like we might remove some common words like to, the, a, articles, some punctuations, commas, etc., etc. So let's not worry about that now. So here we have taken all the unique words, okay, and then we have counted how many times each word appeared. For example, let's take going. So it appeared once in sentence 1, once in sentence 2, once in sentence 3. Okay, so it appeared 3 times. And similarly, to appeared 2 times. And if I take rain, so rain appeared only once in first document. So it appeared only once. Okay, so step number 1, we take all the documents, we count the frequency of all the words in all the documents. Okay, so that's step number 1. And in step number 2, this is specific to each document. So this is term frequency. Okay, term frequency means the number of times the word appeared in the document divided with the total number of words in the document. So if we take the first document, it has 1, 2, 3, 4, 5, 6 documents, right? So the numerator will be fixed at 6. Okay, and only the denominator is 6. The numerator will change for each word. So for example, let's take going. So we have going only once. So 1 divided with 6, that's 0.16. Okay. Similarly 2. So that's again 1 divided with 6, right? So we have each word appeared only once. So we are dividing 1 with 6 for all these 6 words which appeared. We don't have I and am in this document. We do the same for document 2 and document 3 as well. So we have done half of the work. We have computed the term frequency, which is simply the number of times each word appeared divided with the total number of words the document has. Okay. And then we will find out the inverse document frequency. Now the inverse document frequency is simply the log of the number of document which is fixed for a given problem, and then the number of documents containing the word again. So it's the log of, if we take the numerator is the number of documents. So we have 3 documents, right? So the numerator is not going to be changed. Only the denominator changes this time. So denominator, the number of documents containing the word. So the going word, it appeared in all 3 documents. Okay. So it's the denominator also 3. Whereas rain, it appeared only in the first document. So we have only 1. Okay. So here we took the IDF, inverse document frequency, and here we have the TF, the term frequency, right? And then for TF IDF, we simply need to multiply these two. Okay. For example, we multiply the 0 with 1.6. That's for going. So for document 1, the going, it's going to have a value of 0. Okay. And similarly, we can compute this matrix for all the words, for all the documents. Now, so what is it? Why we are doing this as compared to the bag of words? The reason is, if we take the word, for example, going, as you can see, it doesn't appear in any of these documents. The reason is the word going, it appeared in all three documents. So it's not really useful in distinguishing, where are our three sentences? Let me find two. Yeah. So the word going appeared in all three sentences. Okay. So it's not important. I mean, as far as these three documents are concerned, I mean, to distinguish them. Whereas the word rain appeared only in the first document. So the rain, the word is very important to document one. So that's what happening here. Okay, so with this TF-IDF, instead of just counting the number of words in each document, how many times they appeared, we are computing some sort of weightage. What is important, what is not important. I mean, which words are just common across all the document versus which words are specific to some specific documents, right? So that's why for document 1, it, is, and rain, they have high weightage. Okay. Because those are unique to only the first document. So I hope you get a sense of why TF-IDF is better than bag of words. Okay, so that's a second method. But a very big shortcoming of all this is here we have only 3 very short sentences, and we have 1, 2, 3, 4, 5, 6, 7, 8. 8 sentences, 8 words, right? 8 unique words. So each sentences, for each sentence, we have a vector of dimension 8. Now imagine if we have some books or paragraphs of text. Let's say we want to classify some books, right? They will have hundreds of thousands of words, right? Maybe hundreds of thousands of words altogether. So in such a case, each vector is going to have several thousands of dimension, right? Each vector will be huge. And not only that, most of these values are zeros. So this what we call a sparse matrix, right? So the sparse matrix, even though it contains some useful information, most of the values are zeros. Okay. But on top of this, here we are scrambling the text we have, right? We are just breaking it into words, and we are just checking, oh, hey, is this word is there? Is it important? What is its weightage? We are losing the context, or we are losing the semantics of the sentences. We are losing the intent, etc. Right? So the bag of words and TF-IDF, they are okay if you are trying to do some low level work, like maybe classifying the documents, maybe doing some topic modeling, etc. But if you want to do some more complex tasks like language generation or question answering or chatbot like systems, both of these methods will fail. They don't work, right? So that's why we have embeddings. So the embeddings will take the semantics and also the intent of the text. Now, in order to create the embeddings, we just don't take these documents and simply convert them into embeddings. We will have a separate, we'll train a machine learning model. So we will train a machine learning model to create the embeddings. So what we do is we take large corpus of text, the Wikipedia articles, books, news articles, maybe the manuals, etc., etc. So we will take as much text as possible and feed it through an ML model. Now, how exactly we compute the embeddings is not important, as long as we know how to use them correctly. But each object, now this object again can be a simple word or text or a paragraph. We convert this into a vector of fixed dimension. Okay, whether this each object will have 1 word or 10 words, it gets converted into the exact number of exact size vector. Okay, so if we do, so here we have words, we have computed their embedding. So let's say we have trained this black box machine learning model, with all the large corpus of text, which can translate or transform these text into word embeddings. So here we have the embeddings. And then if we want to visualize how these embeddings look like, because we cannot visualize more than three-dimensional space, we can use dimensionality reduction techniques, right? Like principal component analysis, etc. So that we can reduce these 7-dimensional vectors into simply these 2-dimensional points. Okay, these 2 dimensions we can we can plot them on XY space and visualize them, right? So for these 4 words, the embeddings, after reducing them to 2 dimension, they look like this in this space. So as you can see here, we have cat is closer to kitten, dog is slightly far, house is even far. So if we are doing some sort of, let's say, three class classification, we can easily have 2 boundaries lines here. So the cat and kitten, they get classified into the same thing. Now the major advantage with having vectors is we can do the mathematical operations, right? For example, we can add 2 vectors, we can subtract 2 vectors, we can take even the average, or we can compute the angle between the vectors so that we can find the similarities, etc., etc., right? So we can do all mathematical operations, and this makes sense. I mean, with the words we cannot add one word to another, but with the vector embeddings we can do, right? You probably come across this famous example. So here we have man and woman, and then king and queen. So we can translate this man to queen. I mean, yeah. So convert man to woman, and then we'll do some vector operations so that we can move from one to another. Okay. So that's why vector embeddings are very powerful, and they used in all the large language models, the chatbots, question answering systems, etc., etc. All right, that's enough for theory. So let's come back to OpenAI. And yep, so as I mentioned, I already have my OpenAI key, and I store it in my environmental variable so that I don't need to supply explicitly. So in order to create embeddings, it's very, very simple. So import the library OpenAI. So here we have OpenAI, and then embeddings create. Okay. So the input, give your document. This document again can be a word or a paragraph or a sentence, anything, right? And then we supply the model. So here we are using this embeddings model ADA 002, which is the cheapest version, which is the pricing. Yeah. So image models, embedding. So this is the cheapest one. Okay. All right. So what we get, let's see what we get in return. So this is our response. It's a JSON dictionary, and here we have data, and then there is this thing called embedding. Okay. So it's a list with lots of numbers. This vector is normalized, meaning its length is 1. Okay, so that we can take the dot product instead of cosine product, which reduces the computational time. Okay, cool. So we have a vector. Up to this point we have a vector, and then this is some okay, here we have some more useful information like what model we have used. And also here we have the tokens. The prompt tokens is 1. The total tokens is also 1, because for embeddings, as I mentioned, we don't have anything in return, right? We don't have any return tokens. So only what we supplied is counted towards the prompt tokens, which is also the total tokens. Okay. So if you want to get only the embeddings part, we are doing exactly the same thing here, but from the response, we have the data, which is the list, and from the first element we have the embeddings. Okay, I'll show you again. All right, so from this dictionary, we have a key called data, which is a list, and that first element also has another dictionary with the key embedding. We'll get the embeddings back. Okay, so here we have a word called education. We have computed the word education embeddings using these model and it return a vector of dimension 1536. Okay, so the word education gets converted into a vector of size 1536. Now if we look at the first 10 elements, so these are the first 10 elements of the vector. Okay, then similarly here we have another word, let's say sports. We can do the same thing, which again converted into the vector of same dimension, and here are the first 10 elements. Now this time we have a sentence instead of a single word. As you can see, this also converted into a vector of same size. So irrespective of the size of our input, whether it is simply a word or a sentence or paragraph, it gets represented with a fixed size vector. And then we have these 10 first 10 elements of the vector. Okay. Now in later parts of the course, what we can do is as we saw from here. Hey, thanks Harimun Gautam for putting a nice diagram. What we will do is we'll take our embeddings or the vectors of size 1536. We will also do some dimensionality reduction. So we convert these vectors into 2 dimension. We convert these vectors into simply 2 dimension, and then we visualize like here, so that we can also see which documents sit closer to each other, and then when we classify, did they classify correctly, etc., etc. Okay, so we are going to do all sorts of things using embeddings. The classifications, we can use these embeddings even in regression models, etc. Okay, so I hope that gives you some context into what we used before embeddings and why we are using embeddings, what are the advantages, and how to get the embeddings using OpenAI. That's it for video. That's all for this video. Thank you very much.